Okay. Okay, welcome, guys. Thank you for joining the class. We will be starting in 2 minutes. 2 minutes. Let me just connect my audience on YouTube to the live class. So today we'll be looking at set. We'll be learning about set in today's class. Those of you that are on TikTok, welcome to the live class. Welcome, everyone. Okay, I think I'm done. Okay, so the topic today is set. So the first thing we need to know is we need to know what set is, and then we are going to look at the different types of sets and their characteristics. So today's class is more about understanding the basics of set, and then tomorrow we're going to have a second class where we'll focus more on calculations. So for today's class, we'll just look at the basics. So for you to understand the topic, you first need to know what set is. So as a student, if you are asked what is a set, what are you going to say? What is a set? Okay, so let's start from that. What is set? Or definition of set? Definition of set. So a set is a group of objects that have unique characteristics that differentiate them from another group. Okay, a set is a group of objects that have unique characteristics that differentiate them from other groups. That differentiate them so a set is a group of objects that have unique characteristics. These characteristics differentiate them from other groups. Okay, so we can have some examples. Examples is a set containing names of cars. Example of a set is a set containing brands of cars. A set containing brands of cars. Example. A set containing brands of cars. Okay. So if you have a set containing brands of cars, you're going to have, for example, Toyota. You're going to have Nissan. You're going to have Ford, Kia. I'm just using names of brands of cars that are not very long. We also have Mercedes-Benz. I'm just going to put Benz, and so on. So this is a set that, or a group of objects that have unique characteristics that differentiate them from other groups. So once you see these names, immediately you know that this is the names of brands of cars, right? So when we are talking about set, we are talking about a group of objects that have unique characteristics. These characteristics differentiate them from other groups. You can have, for example, a set containing names of schools in a particular city. Names of schools in a particular city. That's a set. You can also have a set containing names of, uh, a set containing feminine names. So in that set, you will see names that are basically for females, right? That's a set. You can also have a set of odd numbers, a set of even numbers, a set of prime numbers. So all these values or all these objects have unique characteristics that makes them to be part of that group. If you don't have those characteristics, or if an item or if a number does not have those characteristics, you cannot be termed to be part of that group. Okay, so that's what a set is. Now, the next thing we're going to look at is set notation. How do you write a set? How do you write a set? How do you write a set? So I'm going to let me wipe this side off. How do you write a set? So a set is denoted by a capital letter. So if you say, remember we have names of brands of cars. So a set is denoted by a capital letter. So you're going to have C. This is set of cars, for example, is equal to, so this sign here, this curved bracket contains all the members of that set. So you're going to see in this Toyota, Nissan, Ford, Kia, and so on. So whenever you write in this form, you have written a set notation. This is a representation of all the values that are in this particular set. So C is equal to the set containing all these brands of cars. Okay, I'm just hurrying through it because the focus is not on the introduction, the focus is on the calculations. Okay, so the members, each of these members of this set are called elements. So the members of this set, they are called elements of a set. So instead of saying members of a set, it is more accurate to say elements of a set. So Toyota is an element of this set, Nissan is an element of this set, Ford is an element of this set, Kia is an element of this set. And then these dots tells us that there are still other brands of cars that are in this set, but the space we have here cannot contain them. So whenever you have a large number of values that you cannot write all down at the same time, you can just put the dots to show that there are still other members or elements of that set. Okay. Let me check on those that are on TikTok. So sorry, those are on TikTok. I'm using one phone to monitor the two platforms, YouTube and TikTok. So, okay, so now we are going to see the different types of sets, types of sets. Types of sets. So the first type of set is equal equal set. Two sets are said to be equal if they contain the same elements. Okay. So two sets are said to be equal if they contain the same elements. So for example, if you say if A is equal to, this is set A is 2, 4, 6, 8. This is set A. Set A is 2, 4, 6, and 8. And then set B is positive, even integers less than 10. For example, these are two sets. The first set is 2, 4, 6, 8. This is set A. And set B is positive, even integers less than 10. So if you want to translate this from words to numbers, B is going to be equal to positive, even integers. So the values are positive, the values are even, so, and the values are less than 10. So what are the positive, even integers less than 10? Can anybody tell us the positive, even integers less than 10? Positive, even integers less than 10. Anybody on YouTube or TikTok? Positive, even integers less than 10. Abubakar, nice to see you from Gambia. Positive, even integers less than 10. The positive, even integers less than 10. First of all, let's write all the integers less than 10. The integers less than 10 are 1, 2, 3, 4, 5, 6, 7, 8, and 9. All these are positive integers less than 10. However, we are looking for the even ones. So that means they're going to be 2, 4, 6, and 8. So at the end of the day, we're going to see that these two sets are equal sets. They are equal sets because they contain the same elements. The elements in set A are 2, 4, 6, and 8. The elements in set B are 2, 4, 6, and 8. So they are both equal sets. Right? Good. So another type of set, so you can be given an equation and you're asked what type of set is two sets of values, okay? So when the set contains the same elements, they must be the same. Then if that occurs, that those two sets are equal sets. Now let's look at the next type of set. The next type of set. Fatima, nice to see you. The second type of set empty set. Second type of set. So a set containing no element is an empty set. Sorry. So an empty set is a set that does not have any element. So the symbol is or. So this, since there is no value here, this shows that this is an empty set. Or you can write it this way. Example of an empty set. A set containing months of the year that starts with the letter A. Sorry, that starts with the letter K. So month of the year that starts with the letter K. If you look at all the months of the year, none of the months of the year starts with the letter K, right? So that is an empty set. So if we say month of the year that starts with the letter K, there's no month of the year that starts with the letter K. So that set is an empty set because there's no month of the year that starts with the letter K. We can also say, example, prime number less than 2. Prime number less than 2. There is no prime number less than 2, so that set would be called an empty set. So an empty set is a set that does not have any element. There's no element in it. So the next type of set we are going to look at is equivalent set. Equivalent set. We're going through this fast. So if you want to check out other lessons that we've done, if you're on TikTok and you want to check out other lessons that we've done, you can just go to my bio, click the link there. If you scroll down, you're going to see all the topics that we've learned: simultaneous equation, quadratic equation, logarithms, indices. We've learned so many topics. You can just see it in my bio. If you click the link on my bio and scroll down, you see all the topics. If you're on YouTube, if you go to my playlist, you see all the topics that we've learned. So number 3 type of set is equivalent set. So 2 sets are equivalent if the number of elements in each of the sets are the same. The number of elements in each of the sets are the same. So if the number of elements in each of the sets are the same, they are called equivalent set. The elements might not be the same, but if the number of elements are the same, then they are equivalent set. Example, if you have m is equal to v, w, x, y, and z, and then n is equal to 7, 8, 9, 10, 11. So if you look over here, the elements in this set are totally different from the elements in this set. However, the number of elements in this first set is the same as the number of elements in the next set. So since they have the same number of elements, they are equivalent sets. So equal sets are different from equivalent sets. Equal sets have exactly the same elements. Equivalent sets do not necessarily have to have the same element, but the number of elements must be the same. Okay? So that's the difference between equal set and equivalent set. Equal sets, the elements in each set must be the same, but equivalent sets, they don't necessarily have to be the same, but the number of elements have to be the same. Okay? So I think we should continue. Let's continue. I'm seeing that the screen on YouTube is wider than the screen on TikTok. So I'm not really covering enough space for those on YouTube. It's because I was working according to the size of the screen for TikTok. Okay, so the next type of set we are going to look at is universal set. Universal set. Universal set. So as I said earlier, today we are just introducing all the terms in set, and then tomorrow we'll begin to solve questions. Okay. So if you are not in the WhatsApp group, you can just send, if you're on TikTok, you can just send me a message at the end of the class so that I can add you to the WhatsApp group. So universal set, that's number 4, type of set. Universal set. So universal set contains all the elements under consideration. Okay, so universal set contains all the elements under consideration. Okay, you can just send me a message on TikTok at the end of the class. Just send me a message letting me know that you want to join the WhatsApp group. Okay. So for example, if for example you have all the states, a universal set containing all the states. I'm using, for example, my country. So universal set is denoted by the sign, this sign. So this is the sign that is used to denote universal set. So for example, you can have a universal set containing the names of all the states in Nigeria. Nigeria, or all the states in Uganda, all the states in Kenya, all the states in Canada, for example. So the universal set can be all the states but under this universal set, which is all the states in Nigeria, you can have subsets. That means you can have smaller sets under this big set, which is, for example, N states with that starts with the letter N. So states starting with the letter N. Sorry, those on TikTok, I went beyond the boundary. Sorry. States starting with the letter N. And then you can have another set, another smaller group. Um, K states with letter K. For example, okay, I had to shorten it because so I don't get beyond the boundary. So this is the universal set, all the states in Nigeria, all the states in Nigeria. And then inside this universal set, we have smaller sets, which is states starting with the letter N. All those states starting with the letter N, they are still part of these states in Nigeria. And you have states with the letter K, that states starting with the letter K, they are still part of the universal set, which is all the states in Nigeria. So if you want to say N, N is only the states in Nigeria that starts with the letter N. But are those states still part of this universal set? Yes. These ones are states that start with the letter K. They are just a smaller group. Remember, a set is a group of objects or items that have unique identity that differentiates them from another group. So K here is a set of states that starts with the letter K. That letter K is their unique identity. That makes them a set. However, they are still part of another set, which is a bigger set, which is all the states in Nigeria. Okay, so that's why I said universal set. This is a set containing all the elements under consideration. So we are considering all the states in Nigeria. That's what we are considering. But within these values we are considering, we can still break them down into smaller groups, which is states starting with the letter N, states starting with the letter K. Okay? And then finally, for the different types of set, we have the subset. The subset. So subsets are like this N and K. Subsets are sets that are part of a larger set. A subset is a set that is part of a larger set. Okay? So let's write that down and then we continue. Most times, students prefer to start calculating, but if you just go into calculations without understanding all these different terms, then you might be confused. And that's what makes many students get confused in set. because they cannot differentiate between a universal set, a subset, an empty set, and all those situations. So subset. This So a subset is a set that is part of a larger set under consideration. Just as we looked at in the previous examples, the sets of states with the letter K, those are smaller groups that are part of the larger group, which is the states in Nigeria, right? So a subset is a set that is part of a larger set under consideration. So in today's class, we've looked at basically 5 types of sets. We've looked at equal sets, we've looked at empty set, we've looked at equivalent set, we've looked at universal set, and now we've looked at subset. Okay, so we can now step into something more that we'll do a little bit of calculation. We're going to look at set operations. Set operations. But for today, as I said, we are not doing any calculation. We are going to be calculating tomorrow. We are starting our class tomorrow at 12 p.m. Nigerian time. 12 p.m. Nigerian time. That means 12 in the afternoon. We started today's class at about 15 past 8. So that means if you can do the calculation, if you are not in Nigeria, then you can just do your calculation. We are starting at 12 p.m. or 12 noon Nigerian time. So set operations or operations on set. Operations on set. Operations on set. So the first operation we're going to look at is union of sets. So the union of two or more sets can be described as a collection of all the elements in the set without repetition. It's a collection of all the elements sorry. Okay. the union of two or more sets is a collection of all the elements in the sets without repetition. So union of sets. So let's say if we have set A, we have 2, 3, 4, 5, and 6. Set B, we have 3, 5, 7, 9, 11. Okay, so these are two sets under consideration. The union of the two sets, which is represented like this, A union B, A union B, A union B. So A union B, we said, is a collection of all the elements in the set without repetition. So what this means, I'm going to write down all the elements I can see in each of the sets without repeating any of the elements, even if that element appears in the two sets. For example, we have 3 here, we have 3 here. That means 3 is twice. We have 5 here, we have 5 here, twice. That does not mean we are going to write it twice. Okay, so we are just going to write each of the elements we see, as long as it appears in at least one of the two sets, we are going to write it down. So 2 appears, so we have 2. 3 appears, so we have 3. 4 appears, 5 appears, 6 appears, 7 appears, 9 appears, and 11 appears. So each of the elements that can be found in at least one of the two sets is written down. Okay. Somebody say, what is the last word? Sorry. What is the last word? This word? Repetition. Okay. So the union of two sets is writing all the elements that you can see in at least one of the two sets. So we can draw a diagram to illustrate this. Okay, you can draw a diagram to illustrate this. But that will be after we've considered the next operation, which is intersection of two sets. So we've looked at the union of two sets. The next thing we're going to look at is the intersection of two sets. Hope we can continue. Hope we can continue. Okay, let's do that. So the intersection of two sets or two or more sets is a set containing all the elements that are common to the two sets. So the intersection of two sets is a set containing all the elements that are common in the two sets. Actually, it can be two or more sets, okay, not just two sets. So let's go back to the previous example, what we did in the previous example. In the previous example, A was 2, 3, 4, 5, 6, and B was 3, 5, 7, 9, and 11. So these were the two sets we considered when we are looking at union of two sets. And for the case of union of two sets, we wrote down all the values that we could see at least one time without repeating. But in this situation where we are considering intersection of sets, we are looking at the numbers, in this case numbers, that we can find in set A and we can also find in set B. So A intersect B. What numbers can we see in both A and B? We can see 3 here, we can see 3 here. So we have 3. We can see 5 here and we can see 5 here. So we have 5. So that means A intersect B contains 3 and 5 because the intersection of two sets contains the elements that are common to both sets. Okay? So the intersection of the sets contains elements that are common to both sets. So now we are going to draw a Venn diagram. Venn diagram. The next thing we're going to ask is, what is a Venn diagram? So a Venn diagram is a diagram representing set operation. Okay. So it's just a diagram that represents that a diagrammatic representation of a set operation or operation of set. So let's draw it. So given that A is equal to 2, 3, what are the values again? 4, 5, and 6, and B is equal to 3, 5, 7, 9, 11. We're expected to draw a Venn diagram. Okay, so let's draw a Venn diagram to show the operations of the set. So here represents the universal set. So the universal set, everything here means the universal set. Okay. And you know that we can write it this way. But we don't bother about that because we are not told about that. We're only told to draw this in a Venn diagram. Okay? So set A, set B, so A has 2, 3, 4, 5, 6. B has 3, 5, 7, 9, and 11. So the first thing we draw out is the intersection. Remember, the intersection are the elements that can be found in both A and B. So from what we did earlier, the intersection is 3 and 5. So this space here is used to represent what is common between A and B, the intersection, where they meet, where they come together. Okay, so we have 3, we have 5. So once you've written out the intersection or what is common, then you go back to A, you write the rest in A, you go back to B, you write the rest in B. Okay, so when you've written out 3 and 5, what is remaining for A is 2, 4, 5. Sorry, 5 is already written, and 6. So 2, 4, and 6. And then you go to B, what is left is 7, 9, and 11. So this is a basic representation of the Venn diagram. Okay. Now we can see that here is the intersection. Here is the intersection. This point is the intersection. But everything we have here is the union. Everything we have here is the union. Remember, the union is writing each of the elements at least once. So we can see that all of the elements in both A and B can be found here, just as we had in our answer for union. In our answer for union, we had 2, 3, 4, 5, 6, 7, 8, 9, each of them written once. So everything here is the union, but the one here is the intersection. Okay. So we're going to look at one more example. We're going to look at one more example. We're going to look at one more example. Okay, let's go. So today we are not giving any classwork because we didn't do much calculation. In our class tomorrow, we're going to do a lot of calculation and then we're going to give classwork. Okay. So given that A is equal to A, B, C, D, B is equal to one, two, three, 4. C is equal to G, B, C, and E. A Let's find A union B. What will A union B? What's A union B going to be? A union B, what's it going to be? What's A union B going to be? Who knows the answer to that? What are we going to have for A union B? Any answers? Ture said empty. A union B, is A union B going to be empty? Are you sure? A union B means the elements that are in both of them combined. Union. Union. The elements that are in both of them. Someone from TikTok, Medic, said empty. Wow. And see, can you see why we needed to learn this? A union B, why is this? Why is it blurry for YouTube? A union B is not going to be empty. Okay, what about B? A intersect B. What will it be? A intersect B. Okay, somebody say 1, 2, 3, 4. Okay, Ture said it's a mistake. Why is YouTube blurry? Okay, let me see TikTok if anybody has given us answer. It's still empty. For union, union means write each of the elements at least once. So for union, we are going to have A, B, C, D, comma, 1, 2, 3, 4. That's the union. That's the union. You write all the elements that you can see in both of them. You write all the elements that you can see in both of them. Then for intersection, it is actually empty set because there is nothing that is common between them. Yeah, medic correct. Number 2. The second one is empty set. Yeah. So intersection is empty, but union is not empty. The same C, if you have A union B union. What will be the answer to A union B union C? What will be A union B union C? Those of you on YouTube, you guys are not giving me an answer. Okay, A, B, C, D, E, G. I think you stopped at G. Did you put E? Okay, correct. You put E. Okay. Okay, that's correct. Elect. That's correct. So if you look at A and C, they have values that are the same. B is here, B is here, C is here, C is here. So you only need to write one of that. Okay. So that will be A, comma B, comma C, comma D, comma E, comma G, comma 1, 2, 3, 4. That becomes the answer. So it's important to know the difference between what's happening to the TikTok network. TikTok has gone off. Why? Why? Okay. So sorry about the internet. TikTok just gave me a signal that the live will be ending soon. TikTok just gave me a signal that live will be ending soon. Okay, so in tomorrow's class, we are going to. What's happening? Sorry guys, those of you on YouTube, the TikTok platform, I don't really understand what it's saying. So I might have to end that class over there. Okay, so let me switch to YouTube and let's conclude the class. So tomorrow's class we're going to do some calculations and we're going to look at some word problems that we can solve using set. Okay, so we should be able to finish the class tomorrow. We might exceed 1 hour for the tomorrow's class, but at least we will do something reasonable tomorrow. Okay, guys. So I think we've exceeded 1 hour for today's class. So we are going to continue tomorrow, 12 p.m. Nigerian time. That means 12 in the afternoon. 12 in the afternoon Nigerian time. That's when we are going to have tomorrow's class, God willing. Okay. So thanks for being here till the end of the class. See you in tomorrow's class. Okay. Have a wonderful night rest. Good night.